In this mortgage case, the couple buys a house for $140,000 and puts $14,000 down, which is 10%. Therefore, the loan involved, or the amount that's going to be amortized over the 20-year amortization period, is $140,000. Subtract the $14,000 down payment. Which is $126,000. The interest rate on mortgages is capped at a maximum of twice per year, and in this case the interest rate for the initial term of 5 years is J2 equals 6.1%, but this couple wants to make a monthly payment. So we need an IQ value. We need to find the monthly rate that is equivalent to J2 equals 6.1. So 1 plus 0.061 over 2 to the 2 over 12 to change it into per month minus 1 equals. That comes to 0.050199 and so on. Store it in A. We'll refer to it as A from now on, the whole value. Next step, we can find the monthly required payment. If we use the formula PV is equal to the payment, present value is equal to the payment minus, or times 1 minus 1 plus I to the negative n over I. In this case, 126,000 has to be the present value of the proposed payments, and the interest rate, since they're monthly, we have to use 1 plus the monthly interest rate, and since we have a 20-year mortgage with monthly payments, we're promising to make 20 times 12, or 240 payments, divided by A, and from that we can calculate the payment by taking 126,000 dividing by this factor, which comes to equal monthly payments of $904.44. For the initial, that's per month. For the entire mortgage, if the interest didn't change, however, this is only valid for 5 years. After 5 years, we have made 60 payments, because there's 60 months in the 5 years, and of the original amount of payments that we were to make, that leaves 180 that are not paid. The balance owing at the end of the 5 years should be the value of the payments that are not made. And since they were supposed to be $904.44, we can find the present value of the unmade payments. 1 minus 1 plus A, and now we've got 180 payments that aren't made over A. That's an 80, which is equal to $107,015.54. So at the end of the 5 years, we still owe $107,000. We started out at $126,000, and we have made 60 payments of $904.44. So we found the balance, we found the required monthly payment. Now what we want to do is refinance for Part C. If the new rate at the end of the term is J2 equals 10%, find the new monthly payment. So what we have to do is start over again with a new balance, and the remaining time is how much we're amortizing this new balance over. So, first of all, since the interest rate is J2 equals 10% now, we go IQ is equal to 1 plus 0.10 over 2 to the 2 over 12. We need to convert it into a monthly rate also, since we still want to make a monthly payment. And that comes to 0.0081648 and so on. I'm going to store that again in another memory, just in case I want to bring back the old interest rate to check this over. So we stored it in a new memory. And then finding the payment, we have the present value of the missing payments still has to be $107,015.54, and it has to equal the value of the new payment, the present value of the new payment. So it'd be 1 minus 1 plus b, and the number of payments that we have remaining to pay off that is 180 now, since we already have used the first 60. And divide that by the number in memory b, and the payment in the second term should be this number divided by the value of this. This number should be a negative 180, of course, for present value. The payment value then, by the time you take that divided by this, is now jumped up to $1,136.79 due to the increase in the interest rate from 6.1% initially to 10% compounded semi-annually. The payment has jumped from $904 per month for the initial 5-year term to $1,136.79. I'm betting that the couple in this case will go for a shorter term at the higher payment, hoping that the interest rate will come down from 10% rather than lock that rate for a full 5 years. Perhaps the best idea would be to lock that for a year, or even go to an open rate mortgage if the trend in the interest rate at the present time is to come down.